Hi there. I have a lesson on mixed expressions and complex fractions, and we're going to work on simplifying those two things. And I have just a bunch of examples of it. In this first one, I have a mixed expression, and we're going to work on simplifying. To do this, we just have to, in this case, subtract fractions. And I think back and go, well, in order to subtract fractions, we have to have a common denominator. So I notice that the first fraction has w minus 3 as a factor in the denominator, but the 2 here only has a 1 as a factor. Therefore, I need to get that common denominator, it's going to be w minus 3, because this 1 is missing the w minus 3. Therefore, I'm going to have to multiply this numerator by w minus 3 and this denominator by w minus 3, because now my second fraction is going to be 2w minus 6 over w minus 3. My first fraction, that doesn't change. That's still the 5 and then over w minus 3. Notice we have our common denominators. We can now subtract. So when we subtract these two, we're going to end up with w minus 3 as our denominator. But now we look at this and go, I'm going to start and go in descending order. So I'm going to start with my variable term. That'd be the 2w. Well, I'm subtracting the 2w from nothing. So 0 minus 2w is going to put me at negative 2w, and then I'm going to have 5 minus negative 6, and 5 minus negative 6 would be plus 1. Now, I cannot factor the numerator anymore. The denominator I can't factor anymore. Therefore, this is our final answer to that first green expression. Now, before we move on, we should double check this, because hopefully you've noticed that I've made a mistake here. Right here, when I did the 5 minus the negative 6, I said it was 1, but 5 minus negative 6 is 11, because 5 plus 6 is 11. Sorry for that mistake. Hopefully you caught it and fixed it right away. Now my second one, we're going to do some division, and when you look at this one, there's lots of division in here, because I have 7/10 technically divided by 14/25. I just have fraction within fraction. Now, I put that little question there that says, what does this mean? And I pointed to whoa, that's not what I want to do. I pointed to the red fraction bar. What does fraction bar really mean? It means to divide. So I'm going to look at this problem as 7/10 divided by 14/25. So what I've done is I've rewritten the problem. It's the exact same problem, just in a different format. Now that we see it this way, I think many of us recognize, well, when I divide by a fraction, that means that I just have to multiply by its reciprocal. So I'm taking 7/10. Now I'm going to divide by 14/25, which again means we multiply by the reciprocal, which would be 25/14. And now it's a matter of multiplying. I always like to simplify before I multiply. I recognize that 7 and 14 both have a factor of 7 in them, so I divide those out. I notice that 10 and 25 both have a factor of 5 in them. Divide the 5s out, and we end up with 2 from the 10 and 5 from the 25. And now I can multiply. The 1 times 5 in the numerator is 5. The 2 times 2 in the denominator is 4. And I just found that 7/10 divided by 14/25 is 5/4. Now, my next example, this just goes back to subtracting more fractions. Remember, in order to subtract fractions, we have to have a common denominator. And to find our common denominator, we need to factor. The first one, nothing to factor there. It's just x minus 6. But this second denominator would have factors of x minus 6 and x plus 4. And then the way I like to find a common denominator is I just ask myself, what is each denominator missing that the other one has? So when I start with this first fraction, it has an x minus 6 as a factor, but it's missing the x plus 4. Therefore, I'm going to have to multiply this denominator by x plus 4, which then means I have to multiply the numerator by x plus 4. And then when we come to the second fraction, I ask myself, what is this one missing that the first one has? Well, nothing, because x minus 6 is already here. That's in the first fraction. The x plus 4 is here, but that's in the first fraction now as well. Therefore, I don't have to do anything to that second fraction. So now I go back, and now I actually have to do the multiplication of the first fraction. I'm going to take the x plus 4 and multiply it by x plus 2, which is going to be a FOIL problem. So I'm going to take the x times x. I end up with x squared. The x times 2, I get 2x. And I'll take the 4 times the x, and we'll get 4x. And last but not least, the 4 times 2, which puts us at 8. The denominator is the x plus 4 times x minus 6. And then we're still subtracting this one. We're not changing it all. I guess I don't need that parenthesis there. We're going to have x squared plus 5x plus 14. I'm going to write the denominator in factored form of x minus 6 and x plus 4, which might look a little bit different from the first one. I just switched the order, but they're still the same. So now I'll go down. Now we can actually subtract. So I'll look at this denominator. Common denominator is going to be x plus 4 times x minus 6. But now my numerator, now I just go through and I subtract like terms. So I see that I have x squared minus x squared. Well, that's 0, and the x squareds are gone. Then I'd move on and I'd look at the x terms. I'm going to go 2x plus 4x, that's 6x, but then minus 5x. So 6x minus 5x, this time is x. Try not to make that mistake that I did on that first slide. And then last but not least, we're going to have the constant. So we have 8 minus 14, and 8 minus 14 is negative 6. Well, now when I look at my new fraction, I have x minus 6 in the numerator as one factor, but I also have x minus 6 as a factor in the denominator. Therefore, this factor is going to divide out with this factor, and all that remains then is 1 in the numerator and x plus 4 in our denominator. Now my next one, I have another complex fraction, similar to the one on the previous slide. Just the one on the previous slide was all numbers. Now I have all variables. But again, I look at this and go, what does that mean? That means to divide. So to divide means to multiply by the reciprocal. So I'm going to start off with my numerator, which is c to the 5th j over r squared. Now, I have to divide that by this denominator, but remember when we divide, it's the same thing as multiplying by the reciprocal. So I'm going to multiply by the reciprocal of what's circled in green. The reciprocal of that would be r to the 4th over c j to the 4th. And now I can work on multiplying these two fractions together. And again, I like to simplify before I multiply. So I'm going to start here and go, well, I see c to the 5th in the numerator and c to the 1st in the denominator. I'll put a little 1 on that to help remind me. Well, remember, when we divide monomials with the same base, which they do, they both have c, we get to subtract the exponents. So I'm going to look at the 5, subtract the 1, I get 4. So I will have c to the 4th. Then I'll go on, I'm going to look at the j's. I see that I have j to the 1st in the numerator here, j to the 4th in the denominator there. I want to have positive exponents. Since the 4 is bigger, I'm going to take the 4 minus 1, which is going to put me at 3. So I'm going to have j to the 3rd, but that j to the 3rd is going to be in the denominator because there's more j's in the denominator. And then last but not least, we have the r's. So I have r to the 4th and r to the 2nd. Subtract, I'm going to do 4 minus 2, which is going to put me at 2, so I have r to the 2nd in the numerator. And there's nothing more to simplify here. Therefore, this is our simplified answer to that complex fraction that we started with. I have one last example here of simplifying a complex fraction. Now notice in this one, I have something I have to simplify here in the numerator. And sometimes I'll have something I need to simplify here in the denominator. Sometimes I refer to these as the big numerators and the big denominators because this is, I'm going to refer to as the big division sign. And in order to simplify that numerator, I have to add these fractions together. So I need a common denominator. Now, the m has a fraction or a denominator of 1. Therefore, my common denominator is just going to be the denominator of the second fraction, which is the m minus 3. Therefore, the only factor this first denominator is missing is the m minus 3, so I need to multiply the denominator by m minus 3, but I also have to multiply the numerator by m minus 3. Now, when I do that, I will now have m times, so I got to distribute this m to the m here, and I'll end up with m squared, and then I have to multiply the m times the negative 3, and I get minus 3m, and that'll be over the m minus 3. But then the second part, nothing is going to change there. I still have 2 over m minus 3, big divided by, and then we don't have anything that we have to simplify in the big denominator. But now I go back to that numerator, and now I can actually add the two fractions together. So when I add them together, I look for like terms. Well, there's not another like term by the m squared, so we just have m squared. There's not another like term like the negative 3m, so we have minus 3m. And then we have to add on to not another like term like that. So we have our numerator of the numerator, but then we still got to get the denominator there of the numerator. So there's the new big numerator. It's still all going to be divided by m minus 1. And remember, when we divide, so this blue division sign there really means to multiply by the reciprocal. So that's what I'm going to do. Now I'm going to do two things here at once. In this next part, I'm going to take my big numerator, and I'm going to factor. So the m squared minus 3m plus 2, that can be factored to m minus 2 times m minus 1. And that's all over m minus 3. But now I have to divide, and like I said, division is the same thing as multiplying by the reciprocal. Well, the reciprocal of m minus 1 would be 1 over m minus 1. And now I notice that I have a common factor in my numerator and in my denominator. So this m minus 1 from the numerator here is going to divide out with the m minus 1 there, which is going to leave us with a final answer of m minus 2 in our numerator, because m minus 2 times 1 is m minus 2. And then in our denominator, we have the m minus 3, because m minus 3 times 1 is m minus 3. And this is our final answer to that original complex fraction that we had way up here at the beginning. So it looks a lot cleaner than how it started. Do all of that work, and we end up with our answer down here. And that is going to conclude my lesson on mixed expressions and complex